Okay, there we go. Okay. So next question, use a trapezoidal sum with the 4 subintervals given in the table to approximate the value of 18 times definite integral from 0 to 8 of E of t. Using correct units, explain the meaning of 18 times this integral in terms of the number of entries. Okay, so again, the best we can do, obviously they're asking for the area under this. So let me clear the screen. So with trapezoidal approximation, you could use that formula, or you could remember to just do you add the two values and then divide by, so it'd basically be, so let's see, how would we do this? So it'd be 0 plus 4 times 2 divided by 2, right, plus 4 plus 13 times 3 divided by 2, plus 13 plus 21, 2 divided by 2, plus 21 plus 23 times 1 divided by 2. Okay, so you can either do, again, well, actually you can't, because the bases are different, so you can't use that formula. So it's best to do, remember the formula here, delta x divided by 2 times height left plus height right. This here is the formula for the area of a trapezoid. So you just really, that's what you should just memorize, really. And that's exactly what I did here. Okay, so this would be 4 plus, oh gosh, what would that be? So that would be, then that would be 34 plus, that would be 44 divided by 2, which is 22. So this would be, let's see, 4 plus 25.5 plus 34 plus 22. That's 85.5. But that's actually not the answer, because look at the integral that they're asking us to solve for. That is the approximation of the definite integral, but we need to multiply that by 18. So that's actually something I did forget to do. We need to do 18 times all of this. So times 18, that would be 1,539. Okay, so this is the value. So that's part one. So for sure, you're going to get 1 point for that answer. I don't know if you're going to get a point for your work, but for sure you will get a point for that answer. Now, where do you think the other point is going to come from in this question?
By explaining the meaning?
Right. So anyone want to take a guess what this represents?
Is that just the hundreds of elephants per hour?
Mm-mm.
For 8 hours?
No. So this is a little tricky because I'm trying to understand what this represents. Because the thing is, E is not a rate. So what would this represent? I'm trying to think the meaning of this. Because what comes to mind here is net change theorem. So remember, when you have context, if you're given the rate of a function and you find its definite integral from A to B, that is the net change from A to B. But the thing is, E is not a rate. E is just the amount of tickets.
Would it be like I don't know, I'm just guessing, probably like the average amount of like hundreds from 0 to 8, or I don't know.
This one's a tricky one.
That's like
Let's
an accumulation.
say it again.
It's like an accumulation.
Yeah, it would be an accumulation.
Is it the amount of elephants that enter the zoo after 18
It's not,
days?
it's
maybe?
entries of names. But say that again though.
This is probably a long shot, but if we're doing the area of how much elephants accumulate, and it's 85.5, and wouldn't 18 just be the amount of days that happens over, or is that just a long shot?
No, I don't think so. Let's see what their answer is. Because I'm a little, if this was rate, I would say that's like the net change, but I am personally confused by this question. So wait, what? This is a mistake. No wonder. I'm like, what does this even mean? What this meant, I think this was a typo, because you can see here in the answer, it's 1/8. Of course, this is the average value. That would be I thought something was up, because I was like, this is weird. This was not supposed to be 18. This is supposed to be 1 divided by 8. That makes it make a lot more sense. That's what the question is asking. Because if you remember, we talked about this. This is the average value. Okay. Remember, the average value is this. This here is the average value of f of x. Okay. This is another incredibly important thing to remember. So what this represents now, I was like, what in the world does the 18 represent? So no wonder this was wrong. Let's divide this by 18 then. Let's fix this. And then I'm going to divide by 8 to fix that. So that's the correct answer. So this is supposed to be 1/8 of all of this. This is 1/8, which we got was 10.6875. And this represents the average value of entries. Okay.
Entries per hour?
No, because again, this is not a rate. E is not a rate. E is the values of entries in hundreds. You can see that. Okay. Again, this is not a rate.
Oh, okay, yeah.
And this is the average value of entries in hundreds, right? So let's see what they say as the answer. So this was 3 points, and this was actually pretty easy. So yes, they did. You see, they did the formula. You add, divide by 2, and multiply by the base. And you do 1/8, and they get that value. And again, you could type out the whole decimal. Like you can type in, this is a very important rule when it comes to decimal answers in the calculator section. You have to put at least 3 decimals. But that doesn't mean you have to put 3. You could put more, but they're only going to grade the first 3. Okay. And they say you can either truncate or round. So like if you cut it off here, that's correct. But if you round it up, that's correct as well. So as you see here, this here is the average number of hundreds of entries in the box between noon and 8. Oh, I should have specified in the time interval 0 to from noon to 8. So here are where the points come from. 1 point earned for trapezoidal sum, 1 point earned for the answer, and then 1 point earned for the meaning. So this was 3 points. So I believe like the way this would work is like if you get the answer wrong because you typed it incorrectly on the calculator, but like at least the setup was correct, you still get a point. And even if you did all of this wrong, but you knew the meaning, you still can get at least 1 point for understanding what this represents. Okay. So yeah, this is one of the easier like calculator section problems. Let's see how this goes. This is where it's going to start getting a little trickier now. Okay. At 8 p.m., volunteers begin to process the entries. They process the entries at a rate modeled by the function P, and now they're actually giving us function P. And this is in hundreds of entries per hour from 8 to 12. According to the model, how many entries had not yet been processed by midnight at t equal to 12? Okay. So this is the rate at which they're processing the entries. Let's take a look here. At 8, we can see here there were 23 entries made. So that means that in the 8 hours that passed, there were 23 elephant names submitted. Okay. God, this is the weirdest prompt. What a weird, they could come up with something more interesting. But okay, so after 8 hours, there are 23 elephant entries. Okay, so I think that's going to be important because now they're going to process the entries. So basically, you're going to find out how many entries did they process and subtract that from 23. I can tell that that's where this is heading. So now P, notice the key. You have to pay attention to the wording. P is the rate. So this is already a derivative. This P represents the rate of change of the of the entries being processed. Okay. So pay very close attention to the wording of what the function represents. P doesn't represent the amount of entries being processed. P represents the rate. So that's important. Okay. So what do you think this would represent? Why am I saying that? What does that represent?
Does that just represent E of T from
No.
12 to 8?
No, EFT is, remember what EFT represents? EFT is from 0 to 8, and EFT represents the amount of entries from 0 to 8. P of T represents the rate at which entries are being processed by the employees from 8 to 12. So what would this represent? Now, P is a rate. So what would this here represent?
I'm just guessing, but would it be like at the rates of like hundreds from 8 to 12, or I
No,
don't know.
what's the antiderivative of rate?
Would it be like the amount of processed entries?
Yes, this is the net change. Remember, if you have here from A to B of f prime, let's say f prime of x dx, of course, this would be f of b minus f of a, and this here is the net change of f. This is the net change theorem. This here is when you're talking about like actual applications, like a meaning behind a rate, right? So here, because P represents the rate, this would represent the amount of tickets processed at midnight minus the amount of tickets processed at the beginning. Hold on one second. My sister's called me. Hold on. Okay, sorry. So yes, again, because P represents the rate, this here represents the change or basically the amount of tickets processed from 8 to 12. So now obviously, because this is calculator section problem, I do not need to actually do the integral because the calculator will do it for you. Now, I did pull up the older version of the calculator because a lot of people have this version. And if you buy it secondhand on eBay, you know, it's probably going to be a lot cheaper. So if you have the newer versions, it's a lot more intuitive because you just have to like fill in the information. But I'll use this one just for those who have the older version. So, because this one, the way you type it is a little weirder. So I'm going to do math. I just click, if you click 9, it gives you this option. So this FN integral stands for definite integral. Okay, because that's the only type of integral calculator can do. So first off, you start by typing the function. Now, again, the only variable you have to work with is x. So even if you're working with t, you just make it an x. It's the same thing. So we're going to do x cubed minus 30x squared. And there's a button here for squared. You can either do the square or you can do raised to the 2. Both are correct. Plus 298x minus 976. Okay, then you have to do comma x because you're basically saying with respect to x, right? Because that's basically saying like the dt, right? The dx, you have to put with respect to x. Then you say comma from 8 to 12. Again, if you have the newer version of the calculator, I'll show you here, which again, highly recommend. This is my baby. This is like, it's amazing. This is one of the, it's overpriced in my opinion, but it's really amazing. See, with the newer calculators, it's a lot more like, hold on. You could see it like it lets you, you can type it in easier, right? But with these calculators, it's a little bit more like, a little bit more tricky. So that's why I'm going to be using this for today. So anyways, when you click enter, there you go. That gives us 16. And what happened?
Mr. Alfonso,
Yeah.
since the calculator kind of just finds everything out for you, do we not need to like do any extra work for it? Like, would that make a difference at all, or when they're scoring it?
Hold on. What's happening here? Oh, no, that's it. Because at least as long you have to show this though. Hold on. What's happening here?
Like, as long as you write the formula and
You
everything.
have to write that, right? Because if you don't write that, you're not showing the grader that you really understand what you're doing, right? By writing it out, I don't think you have to actually type out the whole function. I think this is okay. Like this should be understood as you're finding the net change of P, right? Or of the entries, the processed entries. So I don't think you actually have to write out the whole function. I think this is understood enough. But that's it. You don't have to do any work. That's the beauty of this section. As long as you know how to set up the integral, the calculator will do all the work for you. So all you say is this is equal 16. So this is the amount of tickets processed between 8 and 12. But at 8 hours, there were 23 tickets submitted, as we said, right? It was 23. Yeah. So if there were 23 tickets submitted and only 16 were processed, how many would that be? That would be 7 tickets, not 700, because this is in hundreds, right? This is in hundreds. 700 tickets not yet processed. Wait. I can't English all of a sudden. Okay. So let's see what they say. Let's see what the answers are. Let me take a guess of the points though before we do it. So I'm guessing, because again, it's kind of good to try to figure out where the points are, because then as long as it all adds up to 9, then that's kind of like, that should help you and guide you like what type of work you should do. So I would say +1 for setting up the integral, +1 for 16, and +1 for doing that. So I'm gonna take a guess that this is a 3-point question. So let's see what they say. This was only 2 points. Interesting. Okay. So, well, they did this. What we did was fine. So don't like, as long as the general idea is there, that's fine. We did the 23 minus 16 later, but they just did it as one formula, which is fine. So you got 1 point for the integral. So as I said before, you get 1 point for that, but then you just get 1 point for doing that as well. Okay, so you did not have to set it up this way. I mean, if you wanted to, that's fine. But you have to show, you have to at least write this out, like write the integral and show that you're going to do 23 minus that value. Okay, that's where you're going to get your points from. So this was only a 2-point question. Okay, but again, I can't stress enough, and this is the one thing that people always struggle with. Pay attention to what the function represents. Have to be very attentive to that, because that's how they trick you. Okay. Is that okay? Is that making sense?
Yeah.
This is again, I think this is an easier calculator section problem, but is this a calculator section? Yeah, this is a calculator section problem. Okay. Now, according to the model from part C, at what time were the entries being processed most quickly? So that means, what do you think we're going to have to do here?
You have to find
We're
the
gonna have to test
maximum.
everything.
There were 2 people who spoke. What was it?
I said that, like, if we're gonna have to find the maximum of P.
Yep, right. Because they're asking us process most quickly, so that's when is the rate the highest, right? They're not asking what's the most amount being processed. They're asking when is the rate the fastest. P is already a rate, so you just have to find the absolute max of P. So so we can just graph this. Let's do it. So what I'm going to do here is I'm going to type out the function. So again, you can only, the only variable you can work with is X. So even if you're working in T, just make it X. It's the same math. So X cubed minus 30 X squared plus 298 X minus 976. That's the function. Now, because this is from 8 to 12, I'm going to set the window to 8 to 12. Okay. So I'm going to set the time values or the X values from 8 to 12. So pay attention to those domains so that then when you set your window, you know only to look at that interval. Okay. So let's graph that. Now they're asking here for the absolute max. Now remember, endpoints are candidates for absolute maximums. What I'm thinking they're going to want you to do here is to make a table, okay? Because remember, absolute extremas can either occur at relative extremas or at endpoints. So we see here that there's 2 extremas.
I'm sorry. What numbers did you plug into the window?
Oh, I just changed the X values from 8 to 12, because notice they're saying this function represents T from 8 to 12.
All right, thank you.
You see, so I just changed the X values from 8 to 12. That way I know only to observe that time interval. So what I'm going to do here is first, let's find this 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 relative maximum. So let's do second calculate, and you could do maximum. Again, min and max here are for relative maximums. Okay, so let's do this maximum. Okay, so you have to select a point to the left, a point to the right, and then take a guess. It's weird, I know, but it's because if you have many relative extremas, many relative maximums, you're basically specifying which one do you want it to find. That's why you have to select like the left and right, so it knows to only look in that interval. And then we guess. So we get here at t equals 9.1835. We get that the value is 5.08866. But by looking at this graph, I can see that at 12, it's the highest. So this is a really cool thing you could do. This is another option, is the value button. If you press value, you type in what value of x do you want it to calculate. Let's say x equal 12. So at t equal to 12, p would be 8. So I think it's at 12. At noon, they're processing tickets the fastest. So, and that's because t is the absolute maximum. Or 8 is the absolute maximum speed. Okay, so let's see here. So where do we get the points? Yeah, they wanted you to do a table actually. Is this a calculator section problem? This is weird because it's in the calculator active section. So that's weird. I don't know why they would want you to do a table if you can literally just look at it.
If anything, they probably just want you to like use the value button and just find how we got like x, when x equals 12, it equals 8, and just do that for the rest.
Yeah. So basically, because technically what you're supposed to do when you're going to find absolute extremas is you make a table with left endpoint, right endpoint, and then all other relative extremas. So basically that's called the candidate test. And we talked about that when we were doing function analysis. So you list out your ends because you have to consider the ends, and you also list out all values of x where there's a relative extrema. Now, again, this is if you don't have a graph. Like if you're just going to find the derivative and find the critical points, you list out all the critical points. Actually, I shouldn't do this. I should say you list out all critical points. This is weird to me because this would be a non-calculator section problem, but they put, because I don't know why they would make you do this if you have a calculator, but whatever. This is what I thought they were going to ask for. So this was a t and a p of t. So here they list out, notice the endpoints 8 and 12. They list out the relative extremas and their values. And then of course, at 12, it's the highest. So you get 1 point for considering p prime of t equals 0. Okay. This is weird. Because this is what you would do in a non-calculator section problem. I selected this question because I was looking at calculator only problems. So whatever. Then 1 point earned for identifying candidates. So endpoints and critical points. 1 point earned for answering with justification. And that's it. So entries are being processed most quickly at 12. So this one's not a hard one, but to me, it's silly forcing you to make a table if you can look at the graph, but whatever. This was a weird one. I guess when they say justify your answer, they're asking you to basically make a table. Maybe that's what they mean. Like when they say like explain your reasoning, you have to put it at least like a sentence, right? Just explaining why. But if they're saying justify, you don't need to get wordy. Justifying is just like show proof of how you got that value. So I guess by them saying justify, they want you to show a table to justify that that is the absolute max. Or what else can you do to justify? Like if they ask you to justify a relative max, you can do that test, remember, where you test a number to the left and right, and if you say like plus and minus, you'll be like, oh, this is where there's an absolute max. Like that, this would be considered justification as well. Okay. But okay. And this one was not too hard. But what made this one hard is the wording. Again, and that's the thing. Like, notice these problems, they're really not that complicated. You just have to understand the wording. That's what makes these questions so complicated. Okay. So is everyone okay with that?
Yeah.
Okay, this was a weird question to me, but I mean, I think because that last one was weird. And then they made that mistake here in B, which I was like, what is 18 times? Like, I have no idea what that represents. But by making it 1/8, it was that's what they meant, 1/8. So that was a weird one. Okay. Do you want to do another one together, or you want to try to do the next one on your own?
Can we try the next one on our own and you can
Right.
help us?
But let's go like one at a time. So obviously I don't want, if you make a mistake on the first part, I don't want to carry over. And I think I've explained this to you guys as well. If you make a mistake in one section, but you need to use that answer from that section to do the next section, you won't lose points if the answer was wrong, but you at least used it correctly, right? So you don't get like double points off. They're very fair with the grading in that respect. But also just, there's no such thing as half points either. So like I like giving half points because I'm like, if the idea is correct, you just did it wrong, like I'll give half a point off. But they don't. Like if you did it wrong, you get it wrong. You don't get any points. Even if like the idea was correct, but you didn't do what they asked, you won't get the point. Okay. So let's do like each section one at a time. I'll give you guys like 2-3 minutes to do it yourselves, and then I'll help you guys out. And then we'll go over the points. But I challenge you too to try to figure out where the points are going to come from. Like try to figure out how many points each section is. Okay. So a cylindrical can of radius 10 millimeters is used to measure rainfall in Stormville. The can is initially empty and rain enters the can during a 60-day period. The height of water in the can is modeled by the function S, where S is measured in millimeters and T is measured in days from 0 to 60. The rate at which height of water is rising can be given by S prime of T, which is this function. But again, this is calculator section, so it doesn't matter how scary the function looks like, you have a calculator. So according to the model, what is the height of water in the can at the end of the 60-day period? So let's see if you can figure this out. We just talked about this, by the way. We just talked about what you can do to figure this out. So again, this is calculator. So you just need to know how to set up what you're going to type into the calculator. But the work you don't have to. You basically just need to type or write out what you're going to type in your calculator, essentially. So I'll give you a few minutes. Type your answer in the chat, by the way, and send it privately. Do not send it to the co-host, please. Send it to me, the host. Let me do this on my own calculator so we can see. Very good, Emma. That is correct. But remember, 3 decimal places, you're gonna lose, you're not gonna get the points if you don't type in the correct amount of decimal places. No, Sydney, that is not correct. Very good, Diego, that's correct. Good. No, that is incorrect, it's Jordan. Okay, so here's the T. It is that's the answer. Okay, does anyone want to explain why that's the answer?
Because they're asking for the height of the water at the end of the 60 days.
Mhm.
And they think that S is the function to find the height.
S is the function to find the height, but what function are they giving us?
The rate of change of the height.
Right, they're giving us S prime. So this is the net change theorem, right? This would basically be S of 60 minus S of 0. So this is the height at 60 days minus the height initially. That's the change in height. So that's the net change theorem.
Mr. Alfonso,
Yes.
for my calculator, I'm trying to put integral because I'm hitting second calculate and I'm pressing integral, and it's showing me a graph over and over again.
Wait, why are you looking at the, did you plot this function in the y equals table?
No.
So why are you doing that? This here, these 5 buttons here are only for the graphing section. You do not touch these buttons if you're not doing that.
Oh,
So
do you press math?
you click math and then 9, right? Or you go,
Oh, okay. All right.
and then you type out the function. So you type out 2 sine 0.03x
Okay, that makes more sense.
plus 1.5. Then you say comma x, comma 0, comma 60. Now, also, this is trig, so what should the first thing you do before you even do any math be on the calculator? What's the first thing you have to do?
Change to radians.
Make sure your calculator set to radians, because if it's in degrees, you will get the answer wrong. So yes, that's the answer there. Okay. They didn't specify to say units, but be on the safe side. Okay. Now, let me just ask you a question. What if they said, notice how in the second sentence, they say the can is initially empty. But what if they said there were 5 milliliters initially? Then what would you do?
Would you have to add it to the result?
Right, you'd have to add it. No, you would add 5. Because again, this here is telling us the net change. They're not, so if there was initially 5, this is how much water was added onto that. So then you do 5 plus that. But this is initial, so you start with 0. So this is how much water accumulated. So let's see. This was 3 points. I would not have made this 3 points, but okay. 1 point earned for the limits of integration, 0 to 60. Oh, that's so stupid, but whatever. 1 point earned for the integrand. So saying S prime of t. So you don't have to actually write it in the calculator section. You don't have to write out the whole function. You could just say S prime of t. It's understood. And then 1 point earned for the answer, which is 171.813 millimeters. You don't, if you didn't put the units, you wouldn't have lost a point, but just be careful with that. I always be on the safe side and put units. Okay. So yeah, I would have made this just 2 points, but That's, I guess they were looking for another place to give a point. Okay. So, okay. That's clear. According to the model, what is the average rate of change in the height of water in the can over the 60-day period? Show the computation that leads to your answer, indicate units of measure. Here, you have to indicate units. Let's see if you can figure this out. Again, average rate of change and average value are two different things. So pay attention. They're asking for average rate of change. The second you see rate, slope needs to pop in your head. This one's actually really easy. That is correct, Sydney. Good. But make it private. So send that directly. Is it? Oh, it is. It is. Yes, it is. Sorry. The window's small. I didn't see that. Good job, Emma. No. Dieva, that's incorrect. That's incorrect too, Jordan, but it's close. So, Emma, does your microphone still work? Do you want to explain how you got that answer? And yes, Sage, you got it as well. Yeah, maybe. You could sign out and I'll let you back in. But I'm gonna go ahead, if it's okay, I'm gonna ask Sage if you're comfortable. Do you wanna explain how you got that answer?
I just used the formula for average rate of change.
Mhm.
So I did like S60 minus S0 because it's over the 60-day period, and then that over 60.
Yeah,
And then we already figured out what S60 is, which
Right.
is 171.813 minus 0 over 60, which is just 2.864.
exactly. This here, if you think about it, is 0 to 60 is what we just calculated. That was what we just calculated. Right? So we already calculated that value, so all you had to do is divide by 60. And that's it. So, and that did give you the answer of 2.863557. Again, you could put all the digits if you want. You can either round it up or truncate it, which means you don't worry. Because if you write out all of them, they're just going to look at those first three numbers. But if you want to just end it at 3, you can then round it up. So 2 points. Yeah, basically exactly what you said. S of 60 minus S of 0 over 60. And S of 0 is 0 because you initially start with 0, right? That's it. You didn't have to show this. You just really had to show that. If you do this, you should still get the points because that is essentially the same thing. But they really just needed to see that you understood you divide that by 60. And that's it. And they did specify units. So obviously, when they say specify units, you're going to get a point for units. So yes, that's millimeters per day. Forgot to write that. Millimeters per day. Okay. Okay. So let's take a look at part C now. Assuming no evaporation occurs, at what rate is the volume of water in the can changing at time t equal 7? Indicate units of measure. Oh my God, this one's easy, y'all. This is so easy. But yes, that's correct. I believe so. I don't know what the answer is, but I'm pretty sure that is the answer. So good job. Nope. And that is incorrect. Again, pay attention to the wording of the problem. What is it that they're asking for? And what is it that you're given? Okay. Anyone else got the answer? Okay, no one else? Y'all, this one's an easy one. We're doing C, so assuming no evaporation occurs, what is the rate of volume? So S prime is the rate. So you literally just have to do S prime of 7. That's it. You can just type, you just make T equal to 7. That's it. And you should have got. Is your calculator set to radians? Okay, so let's see what they said. Wait, what? Oh my God, that's not the answer. Oh my, you see, this is where I, oops, this is where I would make a mistake. How silly of me. Darn, I knew something was off. I was like, this is too easy. I knew it, I should have thought about it. Darn.
Did you have to find the rate of change of the volume of the actual
Of-
cylinder?
right, it was the volume.
So you
This,
just do
that's right,
related
S
rates?
prime represents, S prime represents the height, not the volume.
So would you plug in the volume for the height into dH dt?
Well, let's see. So cylinders are like the, cylinders and like boxes are like the only volumes we're not going to tell you because you need to know those. Like those are very easy. Other more complicated figures like pyramids, cones, spheres, they'll give you those formulas, but you need to know the formula of a cylinder. The volume of a cylinder, darn, how embarrassing. See, even it's easy to make those mistakes. So the volume of a cylinder is pi r square h. Right, so what is the rate of change of volume of water? And basically H, if you think of it, is S. So instead of H, let's say S. Right, because they're using S to represent the height, right? So, because remember, a cylinder is basically an area, the area of the rectangle multiplied by the height. So that then gives you the volume of the cylinder. So they're saying here, assuming no evaporation occurs, at what rate? And radius is going to be constant also. Radius is not changing because again, it's a cylinder. It's not like a cone where the radius changes as you go up or down, right? This here, the radius stays the same. So the radius is just a constant. And are they telling us the radius of the, oh, radius 10. They're telling us that. Radius 10. Right, which would be 100 pi s. So V prime would be equal to 100 pi S prime. So V prime of 7 would be 100 pi S prime of 7. So that value that we calculated, you need to multiply by 100 pi. Yeah. And that gives us 602.218. So oopsies. But yes, this is where, again, even me, like, if you're not paying attention to what they're asking for, you can lose points. But I wonder if you would have gained a point for S prime. So 1 point earned for relationship between V and S. Okay, so basically saying V is 100 pi S, right? 1 point earned for the answer. So 602.218. And then 1 point for the units. So cubic millimeters per day. I forgot to write that as well. So yeah, this one, it's not a hard one, but you had to understand what they were asking for. Does that make sense?
Would there ever be questions as simple as what you thought it was?
Yes, like those are normally like the first ones though, like A or B. Normally the first two are like super easy, and then they kind of get harder as you work your way down.
Is it mostly like multiple choice, or will there be FRQ questions like that, do you think?
There are very easy ones like that are multiple choice. But like again, if as you remember with the test, like there are some questions that are like stupid easy, and then there are some questions that are like really hard. So it kind of just varies on which on the questions that they choose to put. But sometimes they're easy. A lot of times though, it's more like context problems. Like, do you understand what the rate is? And stuff like that. Now, if they would have told you like if they would have given you S, right? If they would have given you the equation S and they asked like, what is the rate of height at 7, then you could use your calculator to then find the derivative at t equals 7. And there are some like that where it's like understanding the concept that the derivative is represents a rate. You know, so stuff like that, like sometimes the math is easy. They just want to make sure you understand the wording, right? So it just depends on the problem. But this one in itself was not complicated. It was just you had to pay attention, which again is I was not paying attention. They were asking for volume, not height. So yeah. But again, cylinders, boxes, you need to know those. Remember, the length times width times height is the volume of a box. And then the volume of a cylinder is pi r square h. Like those are the two volumes you need to know. Any other volumes they'll give you, okay? But you do need to know these volumes at least. Okay. And normally when it comes to boxes, they don't do 3 different values. They normally do like a box with a square base. You know, that's like the worst that you'd get. Okay. Okay. During the 60-day time period, rain on Monsoon Mountain accumulates in a can identical to the one in Stormville. The height of water can in the can on Monsoon Mountain is modeled by the function m. So m represents the height. It's not a rate. M is now the height. The height m is measured in millimeters and t is measured from 0 to 60. Let d of t equal m prime t minus s prime t. Apply the intermediate value theorem to the function d on the interval 0 to 60 to justify that there exists a time t from 0 to 60 at which the height of water in the two cans are changing at the same time. This one's interesting because they're telling you the theorem to use. Sometimes they don't specify the theorem, but you have to find out what theorem you need to use to prove it. But they are telling you need to use the intermediate value theorem. So how are you going to give your response using the intermediate value theorem to prove this concept? So this one's pretty easy in terms of the calculations. Now remember, you can calculate derivatives at specific points. That's what the calculator can do. So see if you could figure this one out. Yeah, this one's weird to explain. So basically, so they're saying here d of t is equal to m prime of t minus s prime of t. So for the for the intermediate value theorem, if you remember, the intermediate value theorem was stating if the function is continuous, that's the only thing that matters, that the function is continuous. Then there exists basically every value of y in an interval is covered from A to B. So basically what I would do here is I would find d of 60, right? Which would be m prime of 60 minus s prime of 60. So this is where you can use your calculator to figure this out. You can find the derivative at x equal to 60. And then this one you just plug into s prime, which you already have, right? So I did that work, and tell me if you guys got the same value. I got 69.377. Did you guys get that value for d of 60?
When I tried to do the derivative of m, it
Mhm.
just told me to quit on the calculator.
Did you say at x equals 60?
Yeah. Well, I did x from 0 to 60, and it just
Wait, you're not doing integral, you're doing a derivative.
no, I know I put derivative, but when I did that, it gave me like 27 point something. But when I just did like the actual derivative without putting any values, it
You
just
can't. I've been saying this. The calculators don't do functions. They can only find derivative at points or definite integrals. That's it. There's nothing else a calculator can do. So what you'd have to do here is you'd have to type out the function m. So 1 over 40 times 3x cubed minus 30x squared plus 330x close parentheses, comma, with respect to x, comma, at x equals 60, right? Then minus 2 sine of 0.03 times 60 minus 1.5. Why am I doing minus instead of plus? Because I'm subtracting. Remember, subtraction has to be distributed. Okay, so you're going to subtract this function here as prime. So you got to distribute that minus. Don't forget, that's a common mistake. Or you could have put this in parentheses and done minus all of this, right? Okay, but there you go. I get that value. Then d of 0, I need to find what d of 0 is as well. So I believe if you go back, oh no, this calculator doesn't let you do it. The newer calculators actually like let you go back to like retype a function, so you don't have to like rewrite it all over again. But this one doesn't let you. It's interesting. Let me see something here. Oh, interesting. Okay. So let's do it again. So the derivative of this function at x equals 0 now instead, minus 2 sine of 0 minus 1.5. So we get negative 0. Okay. So those are the two values. So basically, both of these functions are continuous. So we know that the intermediate value theorem applies. So that means between 0 and 12, all values of D exist from minus 0.265 to 69.377. So how could you prove that there would be the same rate? This is weird. Yeah, the wording of this is a weird one. So we applied the intermediate value theorem. I want to see the wording of this. This was only 2 points. Right, D of 0 is less than 0. D of 60 is 69.377, right? So we calculate, so you got 1 point for both. You have to consider both values. So if you just considered one of them, you lose the point. Like, this is interesting. You have to show both to get that 1 point. Because that's important. You need to know what f of A and f of B are in the intermediate value theorem. So because D is continuous, the intermediate value theorem implies that there is a time t between 0 and 60 at which D of t equals 0. Oh, yeah. Yeah. At this time, the heights of water in the two cans are changing at the same rate. So that's how you had to word this one. Does that make sense?
Yeah.
Yeah, the word, this one's a weird one, but this one was very little points actually, which is weird. I thought this one would weigh more. But yeah, that means that, yeah, basically if D is equal 0, that means that the rates would be the same. So if the rates are the same, yeah, that means the two cans are changing at the same rate. Is that what they were asking? Oh, yeah, which the two cans are changing at the same rate. Yeah, they would be changing at the same rate when D is 0. So yeah. So there you go. It's a weird one, but that's how you do it. Okay. Next one. Or do you guys have any questions? Do we move on?
Yes.
Yes, okay. Now again, these questions should take about 15 minutes. I mean, obviously we've taken more time because we're explaining and working through it, but these you need to pace yourself to, like, I would recommend going back and trying to do these problems on your own again and try to keep it under 15 minutes each. Okay, each free response question should take like 10 to 15 minutes to answer. Okay. We've done one like this already. We did this one on the last exam, not the mock, but on the last one. We did one like this. So the graph of the function f is shown above, consisting of 6 line segments. Let G be the function. This is the accumulation of the area from 0 to any value of x. So find G of 4, G prime of 4, and G double prime of 4. Easy peasy, y'all. Let's see if you can figure this out. This one is going to take time, but it's not a hard one to do. By the way, what's the theorem that we're going to be using to figure this out?
Fundamental.
Right, yes, very good. You will need the fundamental theorem to figure this out. I think G of 4 is going to be 0. Let's see. I'll start. So G of 4 would mean finding the area under function f from 0 to 4. So it's going to be positive. There's definitely more area above above the x-axis. So this is like, I think we could see here that this area and this area are going to cancel out. So I'm not even going to bother. I'm just going to calculate this area, right? So the box is 2 times 1 plus half times 2 times 1. So this would be 2 plus 1, which is 3. Right. I didn't do all of them just because I could already tell that like this one and this one are the same. They're just going to cancel each other out. So, but you can if you want. You could do like, you know, the rectangle, the 2 triangles minus the 1 triangle underneath. So that should be 3. So G of 4 is 3. Let's write that here. Now, with the fundamental theorem of calculus, what does G prime of X represent? What's the derivative of G?
F.
Right. So that means G prime of 4 is F of 4. So F of 4 is 0. Right. And then that means that G double prime of 4 would be equal to F prime of 4, which is basically the slope of the tangent line at x equal 4, which that slope would be -2. Okay. So I have a feeling this is going to be 3 points. Yep, 3 points, 1 for each. G prime of 4 is the area under F from 0 to 4, which is 3. G prime of 4 is equal F of 4, which is 0. And G double prime is F prime, which is -2. So those are the 3 answers. This is an easy one. The hardest one was G of 4 because you had to like actually like calculate the areas. But notice they don't care much about the work. They're just looking that you got 3, 0, -2. That's it. As long as you got those three values, you are good to go. Okay. Does G have a relative maximum, a relative minimum, or neither at x equal 1? Justify your answer. So you guys see if you could figure that one out. Pay attention. This, remember, they're not asking if F has a relative. They're asking if G has a relative maximum or neither. Be careful, pay attention to which function they're asking you to analyze. Yes, function F does not have a relative extrema. That's what they're asking. They're saying, does it have it at x equal 1? Okay. Right, so what does that mean? Right, there you go. Right. Okay, good. I think everyone got it. So to find a relative maximum, you need to find where G prime is equal 0. So G prime of x is equal to f of x, and it equals 0 at t equal 1. I mean at many, but they're just asking at t equal 1. So at t equal 1, obviously that's a critical point. So because the sign changes from negative to positive, right? Because now you have to think f is the derivative of g. So this is like the derivative graph, okay? So these values represent the derivatives of g. So if you change from negative slope to positive slope, you have a relative minimum. That's the first derivative test. So you say, this one I think is just going to be 1 point for justifying your answer. So you'd say relative minimum because the sign of G prime changes from negative to positive. So let's see how they grade this. 2 points. Okay, 1 for your answer, 1 for the reason. So because G prime changes from negative to positive x equal 1, it has a relative minimum there. So that's it. Okay, that was an easy one. Okay, part C. Oh, this was only 3 parts. Okay. Suppose that, I don't know why this was a calculator section problem, but whatever. Because we haven't used the calculator yet. So, and if you've noticed, like when I showed in the multiple choice in the calculator section, there were a few questions there that did not require a calculator. So it's like that. Sometimes they dump questions that don't require calculators in, but think of it more like the calculator section. They don't care so much about math. They care more about understanding. So even if you don't need a calculator, the types of questions they like to ask are conceptual. Do you understand the concept? A lot of problems that you see in a non-calculator, in the calculator section, are like theorem problems, because they're just trying to make sure, do you understand those concepts? Okay, they don't care so much about math, quote unquote, in the calculator section because the calculator will do it for you. Okay, last question here. Suppose that f is defined for all real numbers x and is periodic with a period of length 5. The graph above shows 2 periods of f. The graph, okay. Given that g of 5 equals 2, find g of 10 and write an equation for the line tangent to the graph of g at x equal to 108. Oh, so this graph repeats forever. That's basically what they're saying. Okay, so it kind of like continues in this pattern forever. That's basically what they're saying. Okay, let's see if you can figure this out. They're asking for two different things here. They're trying to see if you can like visualize how this behaves. Yeah, it took me a second to understand what they were asking for, but this was not too terrible. Very interesting question. I think you're correct. Yeah, I think that is true. I think you mean to say times 2. Why would you divide by 2? No, but you have to imagine. No, they're basically saying you have to envision this going like this. Oops. Oh my God. That's basically what they're saying, that this is going on forever. Okay, so basically the first part here, find g of 10. That basically means g of 10 would be the area from 0 to 10 under f of x, right? But basically from 0 to 5, you can see that this area and this area are going to cancel each other out, and this area and this area are going to cancel each other out. So that just leaves you with an area of 2, right? But from 0 to 10, you got 2 of these. So you would end up with an area of 4, right? So g of 10 would be equal to 4. Because from 0 to 5, it's 2. So from 5 to 10, it would be 2 as well. So 2 plus 2 is 4. So here, I don't really think they care about sorry, give me a second. Okay, so that should be the first one. Now, the next one, this one's weird. Write an equation for the line tangent to the graph of g at x equal to 108. So first things first, we need to find g prime of 108. Well, which would mean f of 108, right? So let's think about this logically. So basically, if this repeats every 5 values of x, by the time it reaches 105, it's starting all over again, right? So that means you just have 3 units to go. So that would mean 1, 1, 2, 3. So it'd be right here. So f of 108 would be 2, right? So that's the slope. That's g prime of 108. Now I need to find what is g of 108. Oh my. So basically, if this repeats every 5 times, that means that there is 21 of these with an additional. So I'm going to say 2 times 22. So it should be 44. So it should be y minus 44 equals 2 times x minus 108. That should be the value. This one was a tricky one. Let's see what the answer is. Yeah. Ooh, 4 points. Wow. Okay. G of 10. Yeah, so basically, like I said before, the function the function values of g increase by 2 every 5 intervals, or every 5 values of x. So every interval, it increases by a value of 2. So g of 10 would be just 2 times g of 5, which is 4. Now, yeah, they worded it a little different. I don't think they care about the work. See, they just want you to give what's g of 108. They didn't really care for the work, but because I did it in my head, but they're explaining how you get that. So of course, from 0 to 105, like we said, that's 21 intervals, right? Of 5. And then from 105 to 108, that would then be 44. And then g prime of 108 is f of 108, which is equivalent to f of 3, which is 2. So the equation for the tangent line is this. And as I said before, please just leave it in point slope form. Do not try to write it in slope intercept. Just leave it in point slope form. That is an acceptable answer. Yeah, I don't know why this was a calculator section problem, but it's a good one, like a good kind of understanding the concepts. Is that okay? Do you guys follow?
Yes.
Okay.
Yeah.
This one was very conceptual. I'm sorry, what were you gonna say?
Oh, nothing.
Okay. Do you want to move on to the next one, or do you want to do some multiple choice calculator problems?
Could we possibly review one more of these problems?
Yeah. Okay, this is a good one. Okay, this will for sure require the calculator. Okay. Let me zoom in a little bit. Wait, how do I zoom in? Oh, here. Here. So the particle moves along the y-axis with velocity. This is a good PVA one. I like this one. So first one here is, in what direction, up or down, is the particle moving at time t equal 1.5? Why? See, you're gonna get a point for explaining why. Part B, find the of acceleration of the particle at t 1.5. Is the velocity of the particle increasing at 1.5? Why or why not? Part C, given that y of t is the position of the particle at time t equals 0. Okay, let me see, is there part D? Find the total distance traveled by the particle at t equals 0, t equal 2. Okay, so why don't you guys do this? I'm gonna go grab some water. So see if you can solve the first three, A, B, and C. And I'll be back in like 5 minutes. So work on those. I'll be right back. I think this one should have been pretty easy, right? So in which direction is the particle moving at t equal 1.5? So let's find v of 1.5 times sine of 1.5 squared (167). So because the velocity is positive, what does that mean? What does the positive velocity mean? Well, but we're not talking about the x-axis. This is saying the particle is moving along the y-axis. So instead of right, it's up.
Moving up.
Yes, it's moving up. So basically you'd say because v of 1.5 is greater than 0, the particle is moving up. Whoa, oh my God, it just signed me out. So v of 1.5, you see, basically the same wording. So it's because v is positive, right? So that's the first one. Any questions on that? Okay, so I'm going to assume I can move on. Okay, find the acceleration of the particle at 1.5. So basically we need to find v prime of 1.5. Now, again, let me just clarify something here. You have to show v prime. Do not put a. Say v prime because you're showing the reader you understand you need to get the derivative of v. So if you don't put v prime, how are they going to know what you typed into the calculator? So you need to do v prime of 1.5. So we're going to do math, derivative of this function, x sine x squared, comma, with respect to x, comma, at x equal to 1.5. You always have to put comma x afterwards because you're basically saying with respect to x. I don't know why. I'm not sure why that's a necessary step, but that's just the way it is. Now, I shouldn't have done this. We had also calculated that v of 1.5 was 1.167. I shouldn't erase that. Okay. So the acceleration of the particle is negative 1.049 or 0487, whatever you want to say. Now, the question here is the velocity of the particle increasing at 1.5? Well, because remember, to determine if an object is accelerating or decelerating, you have to look at both the velocity and the acceleration. So because the velocity is positive and the velocity is negative, that means the particle is decelerating. So its velocity is decreasing.
Wait, why is v of b prime of 15 -1 instead of -2?
Oh, I'm sorry. It's like, why did I write -1? I don't know. My mind just is -2. Sorry. You're right. I was accidentally like looking at the number above and I typed it incorrectly. So yes, it's negative 2.0487. So because the velocity, so I'd say because v at 1.5 is greater than 0 and v prime of 1.5 is less than 0, the particle is decelerating. I don't know if I spelled that correctly, but that's the concept. So its velocity is decreasing. If you're decelerating, your velocity is decreasing. So let's see what they say here. 1 point earned for saying A of t is v prime of t. You can say A of t, but you have to justify that it's v prime of t. You did not have to do this. This is a calculator section problem, so you did not have to do this. You didn't actually have to find the derivative. You just had to find -2. I don't know why they did this. Well, I do know why, because technically, some of these problems are made so that if you just have a basic calculator, you can still figure it out, even if you don't have a graphing calculator. So like if you didn't have a graphing calculator and you had like a basic calculator, like simple basic one, you still could figure this out, but you'd have to actually do the product rule to find the derivative, right? But you did not, I don't know why they show that, but you didn't have to do that step. You really just had to show v prime of t and then say that's -2.049 or 048, whatever. So no, V is decreasing at 1.5 because V prime is less than 0. So that's that. You didn't actually have to find the, again, in the calculator section problem, you don't have to do a derivative. I don't know why they did it. But I mean, I guess you can, but you're not getting a point for that. You're just getting a point for saying negative 2.048. And then you get 1 point for your conclusion and reason. Now, if they would have said, find A of t, if they would have specified find A of t, yes, you would have had to do the product rule to find that. But they didn't tell you to, I mean, you have to find it, but the calculator does it for you. So I don't know why they wrote that, but. Okay, given that y of t is the position of the particle at time t, and that y of 0 equals 3, find y of 2. So this one's a tricky one because you have to remember the fundamental theorem of calculus part 2, which was this. So basically what I would say here is from 0 to 2. Oh my God. This would be equal to y of 2 minus y of 0. So they're telling you that y of 0 is 3, and you can do this on your calculator, and you already know what this is. So because of that, you can solve for y of 2. So this is a very important usage of the fundamental theorem. They're basically giving you an initial condition. Like you could find the antiderivative. You actually could do u sub. But again, this is a calculator section problem. So you don't have to do that. If you want to, you could do like u sub, find the antiderivative, find the constant with the initial condition, and then solve for y of 2, which you could do. The way this problem is set up is you could do that. But I'm so confused. They're actually doing the work, but this is a calculator section problem. So why are they doing this? This is super bizarre to me. Super bizarre. See, they actually went ahead and did the antiderivative, which would require u sub. But you didn't have to do this. This is super weird. I think that they forgot that this was a calculator section problem because you can do it this way. So basically, y of 2 would be v of t plus 3. This is how, if this was, I'm very confused. I feel like a lot of these problems, they kind of like, they put them all, because this is new, you know, this whole AP Central is pretty new. So I think they kind of rushed in putting in some of these problems. But yeah, this is how I would do it. This is with the calculator, I don't have to do any math. All I have to do is set up the integral. So I say here, the integral of this, x sine x squared, with respect to x, from 0 to 2, right? And then plus 3. So this would be 3.827, which is the answer. See how much faster that was? If this was a non-calculator section problem, that's a different story. You will have to actually find the antiderivative, do u sub, solve for c. That's a different story, but because this is a calculator, you did not have to do any of that. So this is a weird, I don't understand why but notice they're not even giving points for u sub. You only get 2 points, 3 points. 1 earned, I guess, for doing an integral, 1 point earned for what? I think this was wrong. This doesn't make any sense to me. This doesn't make any sense to me because if this is a calculator section, you didn't, this is all you had to do. So I think they're wrong in the way that they're grading this because they're not specifying for you to find y of t. If they ask you solve for y of t, then you would have to do that. But this is weird, and I think they put the answers on this wrong. So like when I grade this next week, I believe I made this due on Wednesday, I think, or on Thursday. I will be checking that you did it this way, not this way. This is stupid. Like this is what you would do again if you forgot your graphing calculator and you just had a basic calculator to work with. Yeah, you could solve it without the graphing calculator, but it's a lot more work. Super bizarre, super bizarre. Anyways, last one, find the total distance from 0 to 2. That's just the net change theorem, which literally you just plug that in your calculator. So we do x sine x squared with respect to x, comma, from 0 to 2. Oh crap, that's right. And this is where I made the mistake. That's right, because I keep getting confused. They're asking for the total distance. They're not asking for the net distance. I didn't pay attention. They're asking for the total distance. So actually, it was the absolute value. My bad. If they were asking what's the net distance or basically what's the displacement, that would be without the absolute value. So I need to go back and redo this. So actually, let me show you where the absolute value is. So you would click math, you go to number, and they have abs. This is for absolute value. And then you type out the function. And then we do x sine x squared. I had to do two parentheses, one to close out the sign, the other one to close out the absolute value. Then I say with respect to x from 0 to 2. See, it's taking a while to calculate it. You could see on the right how it's like calculating 1.7173. And that's the answer that they wanted. See, even I fell for the trap of the wording. You did not have to do this. You just had to do this. This is weird. I'm not, this is how you would do it. You have a calculator. You know what it might be though? I think that this problem may have been from a very old AP Calc exam, like very, very old, from when you had to do things more by hand. So I don't know. But anywho, that's that one. So as you see, when you have a calculator, math, the problems are a lot easier to solve. You just need to know how to solve them. But I think we're pretty much out of time. I don't know if you guys if you guys need to go, but I know I need to go soon. So there's one more question here. Yeah, I need to go as well. There's one more question here, which is like an area and volume one. So try to do that one on your own. But basically, I've helped you guys work on these problems. these are due, when did I make the due date for this? The due date was the 4th, which is, yeah, which is the Thursday. I made it due Thursday at midnight. So be working, like, recommend go back and redo these yourself. Okay, you can watch this video again if you want. I'll upload it later. But try to do the problems on your own. Okay, and redo them, take a picture of your work, upload it, and I'm gonna make it a grade. Okay, but I'm basically giving you a free A. Okay, because we're working through these together. Are there any other questions before we begin or before we end? Okay, I guess not. So, Tuesday, I plan to grade the test. And by grading the test, I mean the free response section. So we're actually going to work on those free response problems together. And then I'll show you guys like where the grades are and how you're going to give points to your peers. And then we'll basically spend all of Thursday reviewing, doing more free response, doing more multiple choice problems. We'll do one more review session on Saturday. And that's it. There's only like 4 days left. And that I'll see you guys before the test. So if there's no other questions, I guess I'll get going and I'll upload this later today. So I'll see you guys later then.
Have a nice day.
Thank you, Mr.
Have a nice
Alfonso.
day.
You're welcome. Thank you.